This worksheet is going to focus on the slope-intercept form of the equation of a line. I do want to remind you, you've seen a couple of forms of lines already. So we've already talked about standard form. So standard form is when you have ax plus by equals c. We've also talked about vertical lines. So vertical lines are always of the form x equals a, where a is the x-intercept. And we have talked about horizontal lines, which are of the form y equals b, where b is the y-intercept. So those are forms of lines that we have already discussed. Now we're going to talk about a new super amazing form of a line called slope-intercept form. And when I say this is super amazing, I really mean it. You use slope-intercept form a lot. It makes graphing lines a breeze, okay? So definition, it says slope-intercept form of the equation of a non-vertical line with slope m and y-intercept b is y equals mx plus b. And a lot of times I'll have students who haven't been in math class in years and years and years, but they remember y equals mx plus b. They may not remember what it is, but they remember hearing y equals mx plus b. So just note that the slope is m, which is the coefficient of x, and b is the y-intercept, which is the constant. So we have the coefficient of x and we have the constant, okay? So the first thing we're going to focus about, so this first video is just going to focus on how do we know that this is true? How do we know that m really is the slope and that b really is the y-intercept? So we're going to kind of like break this down and prove to ourselves that this really, really is true. And then in future videos for this worksheet, we'll look at how we can use slope-intercept form. So again, topic one, how do we know this to be true? Well, we're going to think about a few things that we already know. We can easily find the x and y-intercept of a line, okay? If we're given a line, we know that we can find the x-intercept by letting y equals 0, solve for x. We can find the y-intercept by letting x equals 0, solve for y. Okay, we can find the slope of a line given any 2 points. So as long as we have 2 points, let's say slope and y, or x-intercept and y-intercept, we can use those 2 points to find a slope. And then we have a formula that we can solve, like we can take a formula and we can solve it for a particular variable, okay? So these are all things that we've already learned how to do either earlier in this chapter or in a previous chapter. So let's kind of break this down with an example, okay? So example one, we're going to prove that slope-intercept really is slope-intercept. So it says use the following equation to answer the questions below. 2x minus 3y equals 6, okay? So part A says find the x and the y intercepts, okay? And then we're going to write them as ordered pairs. So for the x-intercept, remember, we let y equal 0, we solve for x. So let y equal 0, solve for x. So I'm going to take 2x minus 3 times 0, because y is 0, equals 6. Well, 3 times 0 is just 0, and 2x minus 0 is just 2x. So I get 2x equals 6. And then I would need to divide both sides of this equation by 2. I need to undo the multiplication of 2 and x. When I do that, 2 divided by 2 is 1. 1 times x is just x. And then 6 divided by 2 is 3. So the ordered pair for my x-intercept for this equation, 2x minus 3y is 6, would be 3, 0. Now let's do the same thing, but this time for the y-intercept. So the way we find the y-intercept is we let x equal 0 and then solve for y. So I'm going to take 2x, which x is really 0, so that's 2 times 0. I'm going to subtract 3y, and that equals 6. Well, 2 times 0 is just 0. 0 minus 3y is negative 3y. That equals 6. We need to undo the multiplication of negative 3 and y, so I divide both sides of the equation by negative 3. When I do that on the left, negative 3 divided by negative 3 is 1. 1 times y is y. And then 6 divided by negative 3 is negative 2. So the ordered pair for my y-intercept, we already let x equal 0, and then we found that y had to be negative 2. So we know at this point where these two graphs cross the x-axis. Most importantly, the y-intercept we're saying is negative 2. Now, for part B, it says use the intercepts from part A that we just did to find the slope of the line. So we have 3, 0 and 0, negative 2, okay? So we're going to say this is x1, y1, x2, y2. And remember, slope is y2 minus y1 over x2 minus x1. And then we're just going to fill those numbers in. Okay, that's a 1 there. It looks kind of funny. All right, so y2 is -2 minus 0, which is y1. x2 is 0 minus 3, which is y1. So let's see, -2 minus 0 is just -2, and 0 minus 3 is -3. And we would simplify that to positive 2/3. Well, that's really cool. So we know the x-intercept, the y-intercept. We know the slope of the line that goes through the x and y-intercept. So we know the slope of this line now. So for part C, it says solve the equation for y. Now, in a previous chapter, we did talk about solving a formula for a specific variable. It's not everybody's favorite thing to do, but you do it a lot in this particular unit, okay? So we're going to take 2x minus 3y, it's equal to 6, and we're going to solve for y. Now, that doesn't mean the x is going to disappear. It just means we want to get y all by itself on the left with everything else on the right. So the first thing I want to do is get the -3y alone. Well, the issue is the positive 2x. I need to move that positive 2x. We would need to move it with subtraction. Okay. Well, on the left, 2x minus 2x is just 0. 0 minus 3y is -3y. And then on the right, we have 6 minus 2x. That's not going to combine into a single term. So I'm just going to rewrite it as -2x plus 6. I like to put the x term first is all. Okay, you generally start with the variable term and end with the constant. So I'm going to put the x term and then end with the constant 6. Now, the last thing I need to do is undo the multiplication of 3 and y. So typically what we've done at this point is we just divide both sides by whatever the coefficient of y is. And we can do that, but I'm going to break it down a little bit more. Instead of just dividing both sides, which is what we're doing, I'm going to divide each term by the coefficient of x. So to undo the multiplication of -3 and y, I am going to divide by -3, but I'm going to divide each individual term by -3. It just makes simplifying easier. So let's see what we have here. -3 divided by -3 is 1. 1 times y is just y. -2 divided by -3, we don't want to write that as a decimal. We want to leave it as a fraction, but we do want to simplify our signs. So -2 divided by -3 is positive 2/3. And then just keep your x. And then let's see, 6 divided by -3 is -2. So we've done quite a bit here. We took this equation, we found the x and y intercept. We used the x and y intercept to find the slope. We then took the equation and we solved it for y. So for part D, it says, what do you notice about part C when compared to parts A and B? Well, I noticed that the coefficient of x is the same as the slope. And I noticed the constant is the same as the y-intercept. And that's exactly what we said up here. We were like, hey, slope-intercept form is y equals the slope times x plus or minus the y-intercept. And that's exactly what we have here. Okay, so we notice that the coefficient of x is the slope and the constant is the y-intercept. So part C is in slope-intercept form. So hopefully that helps you understand where slope-intercept form is coming from and that it really, really is true. The coefficient of x is going to be your slope and the constant is going to be your y-intercept as long as you have solved for y. Okay, so in future videos, we're going to look at finding the slope and the y-intercept from an equation, and we'll also look at graphing an equation using slope and y-intercept, which is a lot easier. It's not necessarily easier, it's less time consuming than point plotting, which we've already done.